So we were asked to look and verify whether this matrix is invertible. And the matrix is invertible if the determinant is not equal to 0. So we found the determinant, we saw that it's equal to 9, so we know that it's invertible. Now one way to get it to find the inverse is to design an augmented matrix with an identity matrix on the right and the actual matrix on the left, and then do row operations to get this to be the identity matrix, and this will complement into being its inverse. So, because think about it, what you're doing is you're going back from that transformation to the identity, and the identity is already an identity on the right. So as you go back on this side, you go forward on this side, basically. And so you get the inverse. And these are the row operations associated with that. I did it, and then I made a mistake, so I had to figure out where the mistake was. But this is correct. But there's a second way to do it. There's a theorem that says that the A inverse is equal to 1 over the determinant of A, which we already found to be 9, times the adjoint of A. And what some of you might be saying, what is the adjoint of A? Well, the adjoint of A is the matrix that is composed of its cofactors. It's first row, first column, first row, second column, second row, first column, second row, second column. That matrix transposed is the adjoint. So let's try to find C11, for example. C11, we know it's going to have a positive sign because the subscript add to an even number. And if we take out in the original matrix 5, -1, 4, and 1, if we take out the first row, first column and first row, we get that the submatrix is just 1. So we know that this one's going to be 1. Now, C12, we take out the first row, second column, we get that the value, the magnitude has to be 4. But we notice that the subscript add to an odd number, which means that it's got to have a negative in front. Now, when we go to C21, we're going to have to exclude the second row and the first column, so we get the matrix is -1, but we notice that there's a negative in front, so it becomes a 1, and that is because these add up to an odd number. And then finally we have C22. Let's take out the second row, second column, we just get a 5. So now we say the adjoint of A in this specific circumstance is going to be C11, which is 1, C12, which is -4, C21, which is 1, and C22, which is 5. We close this, and now remember we have to transpose it. So the way I like to think about it is I look at this row, and I pretend that I slide it over, and I set it over here. So this is going to be -4 and 1. Then I look at this row, and I do the same on the second column. So the 5 is going to drop first, and then the 1. And once we have this, we have to divide it by the determinant of A. So now the A inverse should be 1 over 9 times 1, 1, -4, and 5. What I get is When we multiply a scalar by a matrix, we need to multiply each entry of the matrix by that scalar. And we get this. Now look, we got the same result, but the process was a little bit different. So it's up to you to choose which one you want to use. I like the second one better because I make less mistakes. I tend to make less mistakes. But that is because this is a 2 by 2. Had it been a bigger matrix, like a 3 by 3 or a 4 by 4, perhaps it would have been a little bit easier to do the first method. Another way to do it would be to just put it into a computer and let the computer do the heavy lifting for you. All right, I'll see you next time.